Well, the are comparable approach we just used will certainly work. It's not great. So what we're going to do is make things better using a built-in interface known as comparable. So let's start by thinking about what's not great about what we just did. The first problem is this strange casting we have to do. So if we look at the compare to method of the dog class, we had to take the object that was given to us and cast it to dog before we can get the size. And that just makes the code a little ugly. Ideally, we don't want casts in our code. Similarly, in Maximizer, when we call the .max method, we see that it returns an are comparable, and thus, if we want to actually store it in a dog variable, we have to cast, okay? And make sure you can think about why that is. So in this case, we don't really like this, and it would be better if we didn't have those features. Now the other, and actually bigger deal, is that we just made it up. So are comparable is not a real thing, and as a result, there are no classes out there that already implement are comparable. So if we tried to use our maximizer.max method with strings, for example, they don't implement are comparable, so it will be useless for those. Similarly, there are no classes out there that already do all the things that we want to do, like finding the max, finding the min, finding the median, that work with our comparables. And thus for everything we might want to do that involves comparison, we have to write our own max method and our own min method and our own whatever else. Okay? So fundamentally, the issue is we made it up. It's not a real thing. And unless you intend to rewrite the entirety of the Java standard library, now with our comparable, it's not going to be a very fun time. So our fix actually is going to be pretty simple, and that is we're going to take advantage of an interface built into Java called comparable. So instead of our comparable, the one you and I built, we're instead going to use the one built into Java, and it has one difference from ours, which is that it takes a generic type. And so in this case, this will help us avoid one of our casts by, instead of having to cast this object to the specific type, this will ensure that everything works beautifully. Let's just jump in and try it though. So if we go to our dog class, which implements our comparable, now I'm going to change this. I'm going to say implements comparable, in this case, dog. Okay? Now, where did this come from? This just built into Java. Java yells at us and says, hey, there's an issue here. You didn't give the right compare to method. And all it's saying is this should be dog, right? So if we look at the signature, this type here needs to match what's up here. So we say compare to dog, and I'll just name it dog, and we can delete this line entirely. So we've just saved ourselves a cast. That's nice. And that's the dog class, right? Tiny change. Now we do have to make a couple more changes. For example, actually just one more, I think. If we go to Maximizer, we'll see that the Maximizer class expects comparables, or sorry, are comparables, but we'd ultimately like to be using it with comparables instead of are comparables. So I'm just going to change this by deleting our. And now that should work beautifully. And then finally, dog launcher will work properly. And so in this case, after we do dog d equals dog, maximizer max dogs, we can now say d.bark, and hopefully the largest dog should bark. Let's try it out. Boom, Benjamin says bark. Good. Now we still have a cast here, and if we delete it, it doesn't work. And if we look at the message, we see found comparable but required dog. So that's something we'd still need to fix. There's another change we need to make to our maximizer class. I'm not going to detail it in this specific lecture, but we'll talk about it in about 3 videos, but it's just not something I want to get into right now because it's a bit of a diversion. Okay. So this alternate approach, basically what we did is instead of using our personally made up interface known as our comparable, we used the real one, comparable dog, and as a result, we can now plug into the entire ecosystem. So instead of having to build our own parallel set of libraries, we can use all the ones that already exist and use comparable. So in effect, what we get out of comparable is we can use, for example, there's tons of classes out there that implement comparable. For example, strings. So in principle, we can actually use an array of strings with this max method, and it will work nicely. Even better though, there are lots of libraries out there that already use the comparable interface. So for example, max is already written for us, as you might imagine. So there's a library called collection, and you could say collection.max, give it an array of dogs, and it will find the largest dog, so long as that dogs implement comparable. Okay? So this approach here is much nicer, as you can see, compared to this approach, because it plays well with the existing libraries, and you'll note it also avoids that ugly cast. So that's basically the scoop with comparables, and in the next video, we'll talk about a very closely related idea known as a comparator.